Okay, so welcome back to my maths homework. Fine. So sum of all natural numbers between 100 and 10,000, which are of the form n cubed, such that n belongs to natural numbers, is equal to. Okay, fine. So n cubed between 100 and 10,000. First of all, just find the smallest cube which is greater than 100. So I think 5 cubed, right? So 5 cubed, wait, what? Okay, 5 cubed is 125. Okay, 6 cubed is 36 into 6, which is 18. 36 is 216, so that doesn't work. 5 cubed is the smallest one, I think. 4 cubed is 64, that doesn't work as well, so you got 5 cubed. Yes, plus 6 cubed plus 7 cubed, keeps going like that till. Okay, so you want to have 10,000. We know that 9, okay, it's like 9,000 won't work. 8,000. 8,000 is 20 cubed, right? What about 21 cube, 25? Let's find 25 cube. No, wait. So first of all, just find 21 cube. Okay. let's shorten it up and find 25 cube first. 25 cube, that's supposed to be equal to 25 to 25, 625 into 25. So 25 to 25, 625 plus 600 into 25. So you got 12 and 30 is 150, but you got 100. So you got 15625. So that's bigger than 10,000. So yes, we only have to look between 20 and 25. Fine. Maybe let's just look at 23 cubed. Okay, so 23 cubed, that is going to be what? I really don't want to do this, but fine. So 23 cubed, right? Let's do it like this. 20 plus 3 cubed supposed to be equal to 8,000 plus it's like 20 plus 3 is 23 into 3 into their product, which is into 60, plus 3 cubed, that's just 27. So that hopefully that will reduce my calculations. You got 8,000 plus 23 into 3 is 69 into 60, that is supposed to be 36 and 54, right? So 4140, hope this is correct, right? 36 and 54, that should be correct, right? Plus 27, so it's supposed to be equal to 8,000 plus 4167, right? That is supposed to be 12167. Still it's bigger, so just go to 22 cubed. Hopefully that will give me something. So let's go to 22 cubed. 22 cubed, that is supposed to be equal to 8 into 11 cubed. It's like 8 into 121 into 11 is like 1331, which is 8. 4 2 carried on, so 24 and 2 is 6, 2 carried on, 8 and 2 is like 1068. Okay, fine. So this is just barely bigger than. Okay, so let's look at 21 cube. Why didn't we first check 21 cube itself? So fine, 21 cube versus supposed to be 400 and it's like fine, 20 plus 1 cubed supposed to be equal to 8,000 plus 3 times 20 squared is 400, so 1200 plus 3 times 20, that's just 60, plus 1, so like 8 no 9261. Yes, so till 21 cubed. Fine, so it's going to be till 21 cubed. Now we know that for sure. So 5 cubed plus 6 cubed till 21 cubed, that's the same thing as 21 cubed. Okay, so like summation from r equals to 1 to 21 of r cubed minus the summation from r equals to 1 to 4 of r cubed. I know, so that's supposed to be equal to, what is this thing? So like 1 to 21 of r cubed, which is 21 into 22 squared upon 4 minus 1 to 4 of cube, that's supposed to be 4 squared into 5 squared upon 4, right? Yes, let's see what that turns out to be. So you got 21 squared is 441 into 11 squared, right? So 121 minus this 4 cancels, so you got 4 into 25, which is 100. So okay, I think I should put it as 11 into 11, that will be better. So you got 441 once again, so that gives me 4851, but then that is once again repeated, so 4851 is like 1 6 3 1 carried on, so you got 5 and 3 is 3, 1 carried on, so you got 53361 minus 100, supposed to be 53261. Wow, that's a big number. So yeah, 53261. Fine. And then the next question is the sum of infinite terms of the series 3 plus 5 into 1 by 4 plus 7 into, oh yeah, oh yes, like call this thing as s. So you have s equals to 3 plus 5 into 1 by 4 plus 7 into 1 by 4 squared, keeps going like that. So 1 by 4s, that's going to be 3 into 1 by 4 plus 5 into 1 by 4 squared plus keeps going like that. So 3 by 4s, when you subtract this from that, that's going to give me 3 plus 5 minus 3 is 2, so 2 into 1 by 4 plus 7 minus 5 is also 2, so 2 into 1 by 4 squared, keeps going like that, right? So it's supposed to be 3 plus 2, 2, and then you got like, fine, so 2 by 4 is just half upon, the ratio is 1 by 4, so 1 minus 1 by 4, right? Just a upon 1 minus r, yeah, the formula. So like 3 plus multiply by 4 on both side, on both numerator and denominator, so that gives me 2 upon 3. So yes, it's supposed to be 9 plus 9 plus 2 is like 11 upon 3. So s equals to 4 times 11 is 44 upon 15, something like that. Yeah, so I just should delete it like that. Okay, so the next question is the sum of infinite terms of the series 1 plus 4 by 5 plus 1 7 by 5 squared, plus 10 by 5 cubed. So you got a difference of 3 this time. So once again, just going to use the same strategy. You got s equals to 1 plus 4 into 1 by 5 plus 7 into 1 by 5 squared, keeps going like that. So 1 by 5s, okay, 1 by 5s is supposed to be equal to 1 into 1 by 5 plus 4 into 1 by 5 squared, keeps going like that. So you have 4 by 5s, that's supposed to be 1 plus 3 into 1 by 5 plus 3 into 1 by 5 squared, keeps going like that. So yeah, sum of the infinite terms of this series, like 1 plus 3 by 5 actually, 3 by 5, and then 1 minus 1 by 5. It just turns out to be 4 by 5, so we got 1 plus 3 by 4. Right, not bad actually. Yeah, so that's nice. I got 3 by 5 and then 1 by 5 is like the ratio. It's supposed to be equal to 7 by 4. So our s is equal to, so what is it? Yes, 35 by 16. Yeah, on to the next question. So the next question says that sum of infinite terms of the series 1 plus 4 by 5 plus 7 by 5. Wait, we just did that, sorry. So the fourth question says that summation from I equals to 1 of n. Oh wow. So first of all, let's go from inside out. So you have summation from k equals to 1 till j of 1, that is just j itself. Now let's go for this one. So you got summation of summation, it's from j equals to 1 to I, and you got k equals to 1 of j of 1. That is the same as saying summation from j equals to 1 of I, j equals to 1 till I of j. Yes, so just going to be 1 plus 2 plus 3 till I, right? So just have yes, I into I plus 1 upon 2, right? So now if we go for the next one, which is the summation from I equals to 1 till n of that thing. So summation from I equals to 1 to n of this thing, I into I plus 1 upon 2. That's, now this is getting really, okay, it's like I squared plus I, fine. So for I squared, just have n into n plus 1 into 2n plus 1 upon 6, and then for I you just have n into n plus 1 upon 2. Alright, supposed to be equal to n by what? N by 12. N by 12, we got n into n plus 1. Okay, just factor out that as well. So n into n plus 1 by 12 of 2n plus 1 plus 3, so it's supposed to be n by 6 of n plus 1 into n plus 2, like that. Yeah, not a big deal. Okay, so the next thing is 1 by 4 okay, 1 by 4 1 sorry 1 by 1 to the 4th power plus 1 by 2 to the 4th power plus 1 by 3 to the 4th power all the way till infinity is given as pi by okay, pi to the 4th power upon 90. So that's an assumption. Then the value of 1 by 1 to the 4th power plus 1 by 3 to the 4th power plus 1 by 5 to the 4th power all the way till infinity is okay, fine. So call this thing as, okay, just don't call it anything. So like you have pi squared by 90, don't call it as s, just actually given the value, so that's nice. So this is equal to 1 by 1 to the 4th plus 1 by 2 to the 4th plus 1 by 3 to the 4th plus 1 by 4 to the 4th plus 1 by 5 to the 4th, keeps going like that, which can be written as 1 by 1 to the 4th plus 1 by 3 to the 4th plus 1 by 5 to the 4th, keeps going like that, plus 1 by 2 to the 4th plus 1 by 4 to the 4th plus 1 by 5, no sorry, 6 to the 4th, right, keeps going like that. Now call this thing as s, so it's s plus what's this thing, 1 by 2 to the 4th, that is 1 by 16 of 1 by 1 to the 4th plus 1 by 2 to the 4th plus 1 by 3 to the 4th, going like that, s plus 1 by 16 of, have we seen this before? Yes, we have. Look at this first statement. So pi squared by 90, so that gives me s equals to 9 by 10 of pi squared by 90. Fine, so like this cancels, you got 10, you got 100 over there. It's like, yeah, yes, so it's just pi square by 100. So this thing is pi square by 100, like that. That was nice. Okay, just delete this. Fine, the next thing is the sum of 1 plus 1 plus a into x plus 1 plus a squared into x squared. Oh god, that's very weird. Fine, so what's the general term of this thing? So general term Tn, that is going to be 1 plus a squared all the way till for r equals to 1, I should say tr maybe. So for r equals to 1, you just have r minus 1, right? A to the r minus 1 power. So I think it's supposed to be a to the n minus 1 power, right? Into, so x squared, okay fine, it's like x to the n minus power, n minus 1 power as well. Okay, x to the n minus 1 power. So fine, so it's supposed to be tr is equals to, wow, now this is really interesting. Yes, this is like really interesting. So what is this thing? We know what this thing is, like a to the n minus 1 upon e minus 1, right? That's what this is, into x to the n minus 1. I know. Yes, so a is positive. Okay, a and x both are positive and less than 1. Like this can be written as 1 minus a to the n upon 1 minus a into x to the n minus 1 as well. That's a more suitable format, right? So what do we do with that? Oh fine, 1 minus a, that's supposed to be like a constant quantity. All right, so you just have tr is equals to 1 upon 1 minus a, that's a constant quantity, fine, into, so you got 1 minus a to the n into this thing, which I'm going to write as x to the n minus 1 minus a times ax to the n minus 1. Okay, yes, that's a nice question. That is a really nice question. Now if we sum this from r equals to 1 till infinity, okay, it's the same as summing this thing from r equals to 1 to infinity. So this thing is going to be 1 upon 1 minus a, because that's just a constant, and then we can sum this thing individually from 1 to infinity, x to the n minus 1, minus the sum from r equals to 1 to infinity of, I think it should be r minus 1, but yeah, whatever. It's supposed to be a to the r minus 1 stuff. Alright, so like fine. So what is this going to be? Summation of a times ax of r minus 1 x to the power of r minus 1. Okay, so that's just two different geometric series like that. So it's 1 upon 1 minus a. Okay, it's the first infinite geometric series. So you got x to the n minus 1. When you put r equals to 1 in that thing, the first term you get is x to the 0th power, which is 1. So you got 1. The ratio is x, so 1 minus x minus this thing. So when you put r equals to 1 in this, you just get a upon 1 minus ax. That is a really nice question. 1 upon 1 minus a into, so you got this thing, fine, it's like 1 minus ax minus a plus ax. That is a nice question. It's like 1 minus x into 1 minus ax. Man, this is a nice question. Yes, I love it. Right, just get rid of these things. So it's supposed to be 1 upon 1 minus x into 1 minus ax. Man, this is nice. Equals it's like equals to 1 upon 1 minus x into 1 minus ax. Fine, that is a nice question. So the next question is the sum of wait, so just delete this thing first. Okay, so the sum of 1 plus 2 into 1 plus 1 upon n plus 3 in, okay, so call this thing the ratio. Okay, so call this thing r equals to 1 plus 1 upon n. Okay, and it's still n terms, so this sum that's supposed to be equal to 1 plus 2r plus 3r squared plus 4r the third power till n terms, so till n into r to the n minus 1 power, right? That should work most likely. So if we multiply this by r, so that will give me s times r. This is equal to 1 into r plus 2 into r squared plus 3 into r to the third power, keeps going like that till you have n minus 1 into r to the n minus 1 power plus n into r to the n power, right? So that will give me s into 1 minus r. If I subtract this, that's going to be 1 plus r squared till you have r to the n minus 1 power. Okay, that's a nice looking thing. And then plus this thing n r to the n. So that's nice. So n times r to the n plus this thing, well, that can be written as r to the n minus 1 upon r minus 1, no problem. So first of all, let's see if we can somehow make sense about this. Supposed to be equal to n times r to the n plus 1 minus, yeah, fine, it's like r to the n minus 1. Now we can substitute the value of r as 1 plus 1 by n. Okay, so what does that give me? Yes, like call this small r maybe, because we used that. So that gives me r minus 1 is 1 by n. So n times r to the n, and then this thing is supposed to be 1 by n, goes on the top, you get n times r to the n minus 1. Okay, right, I mean, yes, r minus 1 is in fact 1 by n, so not a big deal at all. So n times, actually 2n times r to the n minus n, right? That's nice. That is a nice thing. Wait a second, no, not yet. It's supposed to be negative, and I always forget this, man. We were subtracting, so it cannot be positive, right? If you subtract, what did I do? So if you subtract this thing from that thing, you get negative n r to the n thing, so it's supposed to be negative over there. So it cannot be like that, it's supposed to be negative. So yes, some stuff cancels out perfectly. So it's supposed to be, wait, what? No, wait, that's not nice. R minus 1 is obviously 1 by n, so that goes on the top. You got r to the n minus 1. Wait, how is that? That's very weird. This cannot be negative. Okay, so you got 1 plus r till you have r to the n minus 1. Okay, it's supposed to be r to the n minus 1 upon r minus 1. Perfect. You got this thing. Yes, I don't know what's incorrect about it. So got what? Is there supposed to be something which is incorrect? Got n minus 1, right? It's supposed to be till n turns. So for the first term it's just r to the 0th s times 1 minus r is equal to 1 plus r squared. That does look very correct. So yes, it is still r minus 1, and then you got minus n times r to the n, which is in fact this thing. So like r minus 1, it's 1 by n, so n into r to the n power minus 1 minus this guy is supposed to be, why is this negative suddenly? Oh yes, because it is 1 minus, okay, that's fine. So 1 minus r is a negative quantity, right? So yeah, we are going correct with this. So that gives me negative n, right? So s equals to negative n upon 1 minus r, which is nothing but n upon r minus 1. But guess what, r minus 1 is nothing but 1 by n. This turns out to be n squared. Yes, a very simple answer for this complicated thing. Wow, that was nice. So it just turns out to be n squared. Okay, move on to the next question. The value of summation from, let's delete this thing. Okay, so the value of summation from r equals to 1, n equals to 1 till infinity of negative 1 then n plus 1 power into n upon, oh yes, fine. So s is equal to, what can we say about it? If you put, fine, actually this can be done in a different way. So this thing can be written as negative 1 into negative 1 by 5 raised to the n power times n, right? That's much better. So I know it's supposed to be negative in that case, fine. So call this thing as s equals to, if you put n equals to 0 in, we don't need 0, just put 1 in there, right? So you will have negative, take that negative 1 common, so you have negative of, and you put 1 in there, you get negative 1 by 5 of 1. What should we do? Okay, it's got n plus 1 power. Fine, just go ahead with this. Yes, we should be putting n plus 1, shouldn't we be? So negative 1 raised to n minus 1, that's the same thing as saying negative, oh yes, that's much better. That, okay, we can write in a better format. This is the same as negative 1 n minus 1 power, okay, because yes, and yeah, looks like negative 1 raised to n plus 1 power, that's supposed to be negative 1 second power, and then negative 1 n minus 1 power. This thing is just 1, so it is negative 1 n minus 1 power, and then you got n upon 5 into 1 by 5 raised to n minus 1 power. That is much better. So now we have that the ratio is n by 5, negative 1 by 5 is the ratio, and you got n minus 1 power, fine. So our sum, that's supposed to be equal to, when you put n equals to 1 in that, you just get 1 by 5, and this is just 0, plus 1 by 5 into negative 1 by 5 plus 1 by 5, no wait, actually 2 by 5, and then you got 3 by 5, yes, into negative 1 by 5 squared plus 4 by 5 into negative 1 by 5 cube, and it keeps going like that. So now if I multiply this by 1 by 5 once again, actually I should say negative 1 by 5 once again, so negative s by 5, that is supposed to be, you will have 1 by 5 into negative 1 by 5 plus 2 by 5 into negative 1 by 5 squared plus 4 by 5, actually 3 by 5 into negative 1 by 5 cube, keeps going like that. Now if I subtract this, I will get 6 by 5 of s, that is 1 by 5, and then 2 minus 1 is just 1, so you got 1 by 5 of negative 1 by 5 plus what you got, yes, 3 minus 2, that will give me 1 by 5 of negative 1 by 5 squared. So 1 by 5 of negative 1 by 5 squared, and it keeps going like that. So this is the same as saying 6s is equals to 1 plus negative 1 by 5 plus negative 1 by 5 squared, keeps going like that. It's just 1 upon the common ratio is negative 1 by 5, so like 1 plus 1 upon 5. That's supposed to be equal to, you got 6 by 5 over there, so this is 6 by 5 goes on the top, you get 5 by 6. So s equals to 5 by 36, I think. So yeah, that was my homework. Hope you enjoyed. I will see you in the next video.